Kubernetes Basics. We cannot start with Kubernetes if you don't know what the Docker is by itself. And I want to be very practical here and start with a very simple thing. When you think of Docker, you have to think of two main ideas, only two main ideas. That's simple as that: image and a container. That's it. That's all the basics of the Docker. Image you can consider as a template or a class if we speak in object-oriented programming approach. Image is a deliverable item. You can build it, push it, pull it, and use it. Image includes all the dependencies you need to run the code, to run the container. Operating system, yes, seriously. Libraries, code, and whatever you may need to run and execute some piece of code. We use image to create a container. And what's a container then? Container is like an object of a class if we speak again of object-oriented programming, or implemented filled template. We create container based on an image. And we run container as a program, execute a command inside the container, and stop it. And then, how it works, I would better show you in a real practice because, well, it's so simple, so it's easier to watch than to try to explain. Let me show you my... Yeah, and I guess I have to increase the size, otherwise you will not watch anything. So, how it looks, can you see my screen? Yeah, I think it looks pretty good. Okay, so if we want to create an image to pack our software to be able to run everywhere, we have to start with a Docker file. So what's the Docker file? Docker file is a really simple concept. It's the file of instructions explaining to Docker what has to be included into the image we are working with. So that's a very simple example. And every step is an instruction telling Docker to something. For example, first line from Python, slim, it means what I will not write my image from the scratch. It's just too many things to do and I don't want it. So I prefer to use prepared image, and Python in this case is an official image prepared by Python team. And I want to use a slim version, so it will be smaller one, not well big one, but one smaller size. And I want to copy my local code from this folder to the image, so I will have it there. I have to install the requirements. So run is a directive for Docker, and what exactly to run? Pip install requirements. If you have experience with Python, you understand what happens there. If you don't worry, it's very simple. We just ask Python manager to install requirements of my program. At the next line, I ask Docker to open port 80 for me because I'm going to do some actions with HTTP request. And the last line is command Python launch HTTP server at port 80. And that's interesting point. You say like, okay, we built a Docker image. This command will be, this line will be executed as well, and image will run then HTTP server. Perfectly wrong. Because image is something what can't run. Image is just a package. You cannot run an image by itself. You need you need a container to execute this line. So this command tells to Docker what when you run a container based on this image, this command will be executed. Simple as that. And then if you want to build an image based on that, you say Docker build, and you specify what to build. In this case, I want to build local directory, so I just set a dot to specify the local directory. It will work pretty quick because I did the hardest work for you already. I pulled the base image. I pull image with the Docker pull and I have it here. So all the steps are executed and I have my new image here. And that's the ID of an image. If I want to run a container based on that, I can say Docker run. I want to forward port 80 because, well, I want this application to be available at my local host at port 80. I want to run it in detached mode. And then if I want to run a container, I must specify image. So we go D6 F1, so I can just put the beginning of the image name. Sorry, oh, port is already allocated, of course. Okay, so I will just simply run it at port 81. And nothing happened, just this long ID. What does that mean? We can check with Docker PS to check the list of the process. And I see 2 containers running already. One I started getting ready for this workshop, and one I started right now. And this number here is the ID of the container I just started, and it's much the beginning of this ID, just using short ID to make it easier for you to read. And then, yeah,
Alex,
yes?
If I may stop you there.
Yep.
Perhaps you want to scroll your screen up a little bit so we are not obscuring the Docker IDs.
Sorry, everyone. I will simply hide myself. Thank you so much.
Yeah.
Yes. So I hide myself. Sorry, everyone. Yes, I forgot about this overlay all the time. Sorry. And Bettina, I think you are fine because, well, it all.
Well, I'm only hiding unimportant
Yes,
stuff.
yes, you are hiding
But you hide
only names.
IDs.
Yes. Okay, good. And now I can ask for data using this port 81. And my application answers, but I guess if you don't, use it to use curl, which is very fine when you want to open it in browser. So let me open it in browser, perfectly fine. And I will go to localhost port 81, and I again get hello world because my application is running. Very well, that's simple as that. So I just created an image and instantiated a container out of this image. Let's move on. And last things you do with your image. First of all, I want to stop my containers, or better to make it quicker, kill my containers. Boom. So my containers are done. I can ask Docker PS again, and no containers are running. Great. But then, so I've used an image, and imagine like Bettina wants to use this image now, or any one of you. So I want to share this image. In order to share this image, I first have to set a tag to this image because, well, ID is not so useful. And I will tag it like others architect. It's my ID at Docker Hub, very simple. And when I will call it hello world. And when I have to specify which exact image I want to tag. So it will be ID of an image therefore, and that's the ID of an image I've used.
Hang on, Alex, you want to share your terminal again? Because you're still in the browser.
My God, sorry.
No worries.
You are right. Oh,
you might just want to show that again, what you just did.
Yes, exactly. And I will hide you for a second as well, because now you hide some information.
Yes, please hide me. Go ahead.
Good. So let me get back. Sorry, I forgot to switch you to my terminal. So as I want to share the image, I have to name it somehow, because it's not convenient to use all those long IDs. So I have to do Docker tag to set a tag for an image. And I call it this architect because it's my name at the Docker Hub, place to store the images. And I will call this image hello world because that's what it does. It answers hello world. And then I'm going to use the ID of this image. Short ID of this image is going to be D6 F1. I know it because Docker printed me this ID. Successfully built, blah, 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 blah. Good. So, but okay, I set the name for it, but now I have to somehow share it. And to do it, I do Docker push. To push the image, push where? to the repository. We use Docker Hub as the default repository, so I don't have to change anything there. And I just say Docker push hello Hades architect, hello world. And it may take some time, but usually it goes very quick because Docker images are very well optimized. So you see those layers already exist. That's because image consists of layers, and if a layer was already uploaded to a Docker Hub, it will be reused. So I can work with a huge image like 1 gigabyte image size, but if it was uploaded already, I don't have to upload it again. Every layer will be checked. If it exists, it's considered as uploaded. Very well. And now everyone who wants to use this image can easily does Docker pull Hades architect / hello world. And you will have this image very soon because it's a pretty small one at your laptop or whatever computer you are using. Good. So let's go better. Let's go further. First, I'm going to switch back to presentation and I'm going to show our heads. Hello, Bettina again. That's me again. Good. And then next thing. So we use just C in action, Docker build, run, ps, stop, tag, push, pull. It takes some time to learn how it works, but now you at least briefly understand Docker file located on the right side of the screen. Now, some of you may know the virtual images and virtual machines and images of these virtual machines. And you may say, like, why do we need containers to pack all the dependencies and distribute all the software if we already have virtual machines? Answer is very simple. Virtual machines provide better isolation, although modern Docker also provides pretty good isolation, but they also bring very strong additional expenses because virtual machines need to run a guest operating system. So as you see on the left part, if you want to run an application with a virtual machine, you're going to need your infrastructure, of course, then host operating system, hypervisor, and then guest operating system, and then all the binaries and libraries you need to run your application, and only then the application. And container works differently, and that's a great thing if you think how it works. Containers simply run your application as a process of a host machine, the base machine, without the requirement to run these guest OS. And that's really great because you can run much more now application with much smaller expenses, is much less amount of additional expenses to run the guest operating system. Because basically you don't need guest operating system. What you need is your application running. Who cares about the operating system except of system administrators, but they're boring? Sorry, guys and ladies.
So everybody who complained about the virtual machines in the DS201 course, this is really for you, right? It will be much, much easier with Docker containers and with Kubernetes. So this is exactly the reason why we don't like the virtual machines. They're too heavy, they take a long time to download, and they're hard to administer.
And they also take a long time to start because when you start a virtual machine, it takes time to start up the operating system. But when you start a container, usually only one process is starting. So that's the container I just built recently. It consists of a Python base image and this my little index HTML file. And basically that's it. And when you run this container, you will run only single Python process in your host machine. You don't, it's based on the Linux system, but you don't run this Linux. You run only this process. Okay, let's move on. We're a little bit out of time. Good. So there are a lot of options and a lot of things to consider while running Docker. You think of images and containers, yes, but you also have to think of data volumes, because Docker stores data. Normally you contact your local data using volumes, and you have to manage networks as well, and so on and so forth. And there is a lot of things to work, but the initial introduction, I hope, is simple enough to get in a second. And there are also a fancy picture showing how Docker works with images, runs containers based on those images, and pushes these images to the registry for everyone to reuse that. And that's how it looks when you want to run Cassandra with Docker. So you already know command docker run, but very often you want to give a name for the running container. So you would run docker run / name and specify the name. You want to specify it run in detached mode, so -d. You have to specify environment variable Cassandra broadcast address and give this address. You have to open some ports. You have to mount some volumes, because volumes is the basic to map some data from your container to your host machine, and you need that. And then you specify the image. So this docker run command looks much longer than you've seen me running this simple Python web server, of course. And it got even worse if you want to run multiple containers at once. So for example, you want to run free Docker, free Cassandra nodes cluster, or you want to run a regular web application, not as hello world one as I've created, but the normal one. What you have to think about, we have front end, we have back end, we have database, maybe we have some caching layer, and boom, we already have 4 different containers, and we have all of them with some requirements, this open ports, set environment variables, mount some volumes, and one depend on another, so you have to run backend only when your database is ready, for example. Altogether, your Docker run will be, first of all, you will have multiple Docker run commands, and second of all, you are going to have many of them, and that's kind of get fragile. Here comes our first big helper, Docker Compose. Docker Compose is a great thing. Docker Compose, and also very simple thing. Docker Compose is a simple wrapper, very simple thing, which allows you to describe your requirements for Docker in a simple YAML file, just as simple as you see on the screen. And instead of running dozen Docker run commands, you simply say Docker Compose up or Docker Compose run, and you have it running, and Docker Compose will convert this file to Docker commands for you and do all the required Docker runs. And the same if you want to stop system, and you don't have to say Docker stop 4 times. You have to say Docker Compose stop, and it will set down all the system you are running for you. So, and of course, it's much more transparent because it's a Docker Compose YAML file. You can put it under Git and have it in your GitHub or whatever Git repository you are using. It's really great and much more and much better. So you have everything, and then you want to run something, you simply get this file from your colleague and do Docker Compose up, and all your things is running and available for you, and you don't have to remember a dozen of Docker Compose commands. And now, there is a big problem. Docker Compose is great, but is it enough for us? It's still not enough. Why? The biggest problem with Docker Compose is designed to work on the single host only, so on your laptop to say. Docker Compose is not for production usage. And the main thing, if you want to run your Docker containers on multiple machines, which is a very often used case in production with big applications, then of course Docker Compose will be not enough. It's technically doable, but I very not recommend you to try to run your system on multiple hosts with Docker Compose. It's possible, but there is a lot of pain. So here comes Kubernetes. What is the Kubernetes? It's a management system for deployment, scaling, and management overall of the containerized applications. So how it works and what it does is a very simple way. You have, let's say, 5 servers Doesn't matter if it's a bare metal servers or anything else. That's not the point now. Virtual machines, let's say, and or instances on AWS like we use. And you want your application to run like you want 3 nodes of a backend on 3 different machines, database to run on 2 different machines, and that's how you want to care that. And again, if you don't have Kubernetes, you still can do it all manually. You can run manually Docker commands, and you can set up a Docker network over these machines, and it will work. But trust me, you don't want to do it because it just will be too hard. Okay, with 5 machines and a dozen of containers, maybe you can manage that. But as soon as you have hundreds of servers, thousands of servers, dozens, thousands of containers and images, it's not going to be possible. So Kubernetes as its management system, what runs over your hardware or virtual machines nodes and manages containers for you. And it executes a lot of different tasks because management of dozens, thousands of containers, it's not a simple thing. Batch commands execution, kinds of packaging, self-healing, scaling, and auto-scaling is possible, service discovery, rollout balancing, automatic deployments and rollbacks if something went wrong, secret management to keep your passwords safe, storage orchestration, and many other things. That's the job of Kubernetes. And main hero for us working with Kubernetes cluster is kubectl, which literally means kube control. It's a tiny console tiny console application which you run to give commands to Kubernetes cluster. And kubectl works with a master Kubernetes node using REST API. So that's a simple thing to run REST commands to the Kubernetes master. And Kubernetes master gives orders to Kubernetes nodes. Node is a worker machine in Kubernetes cluster. It can be a bare metal or virtual machine or whatever. And well, technically, it's a very complicated setup because it's not easy to run dozens of thousands or more. Maybe, I don't know what's your size of containers. So there are a lot of different things to make it easy to use, if you can use easy with Kubernetes, because, well, it's not a simple thing. There are etcd, which is a key-value storage. There is a controller manager to have a control over worker nodes. There is a scheduler to schedule some jobs, and API server with REST API to set it all up. And kubelet is the node agent what runs on each node. Like kubectl is the way for you to give orders to Kubernetes master. So kubelet is the agent running of every worker and executing these orders to run a container, take down a container, and things like that. Kubeproxy, Kubernetes networks proxy runs also in each node. It's, well, networking as Kubernetes is pretty complicated because you have a really very granular control over what's allowed, what's not. So they really care about the safety and all the kind of network connections. That's the work of a Kubernetes network. And kubeproxy is responsible for the networking on the per worker. And now, I told you, when you think of a Docker, you have to think of images and containers. Good. And now we add one more concept which brings Docker, which brings Kubernetes. I don't care if you forget about kubelet or kubeproxy. That's not the point right now. But what you have to remember is pod. And what is a pod? Pod is a collection of containers what run on a single host together, and they are grouped. Like, imagine if we speak of the Cassandra, we want to run Cassandra container, of course, but for us, just Cassandra, plain Cassandra is not enough because we want to have a management application alongside with Cassandra, so call it sidecar or management API. And this management API doesn't make sense without a Cassandra. And Cassandra for us, as we cannot manage it without management API, also doesn't make so much sense. And they group them together, two different containers working together in a single pod. So you can think of a pod as a group of containers working together for a similar purpose. Good. And final thing, very important thing for us is a namespace. Well, what is a namespace? You can think of the namespace as a logical grouping for different resources. So I may have some pods, I may have some services, I may have some another resources of Kubernetes. And if I have really a lot of them, it's hard to manage them. Some of them responsible for monitoring. Some of them responsible for database, some of them responsible for the application A, some of them responsible for the application B. If you keep it all together, you know, it's like a monolith architecture. You have all together and it's hard to manage. So namespace allows me to group things together, what works together, and then it makes me easier to manage them because I don't get like a list of resources for everything. But with a specified namespace, I receive the exact group of resources I'm interested right now, like monitoring subsystem, for example. And in our case,
so you will have.
Yep.
I just wanted to say that everybody has a default namespace, and it might just something that catches you out when you create your pods that you don't create them in the right namespace and you don't see them when you try to access them. So something to pay attention to, right? When you create your pods, they're associated with a namespace, and if you don't mention it, it will be created in the default namespace. So we want to group our pods together so that they're at our disposal and manageable.
Yes, exactly. Okay. So, and today we will work with the namespace Cass Operator because the main hero of today is Cass Operator, Cassandra Operator, but data stacks, and we are getting very close to it. So now very important thing, storage. The bless and the curse of Docker containers, they should be ephemeral. You don't treat them like a very old DevOps joke. You treat them like a cattle, not like the pets. What's the difference between pets and cattle? Pets have names and cattle has numbers. And if your pet is sick, you will bring your pet to a veterinarian. And if your cattle is sick, you maybe just replace it. And those ephemeral containers need, it works very great as long as it's stateless. But as soon as it's getting stateful, you got some problems storing your things. And if your container wants to work with persistent data, so like wants to store some data, which is very often use case, it needs to work with a persistent volume, which must be defined in Kubernetes. And to get this volume allocated for this container or pod, as we are in Kubernetes already, we think not of containers, but of pods, it creates a PVC, persistent volume claim. It's the claim to receive access to a persistent volume. We will work with it closer in a little bit. So persistent volume is a storage resource provisioned by administrator. Persistent volume claim is a request to claim a persistent volume. And storage class describes the parameters for a class of a storage by which persistent volume can be dynamically provisioned and delivered. And storage class is important things because to run deployments for different clouds, for example, you may need to use different storage classes. When we speak of ecosystem of Kubernetes and all the related technologies, it may be as how to say it? It scares people usually when they see this picture as it scares me. Don't worry. If you get closer to a Docker and Kubernetes, you will at some point understand all the steps of it and how it works together. But today we focus only on the main things. We discussed some basics of Kubernetes, and well, this is kind of a joke. We don't know Kubernetes yet, but we will, because we are going to work with an exercise. I will do exercises for you, and then later you will do them manually on your laptops or our cloud instances, and after that you will be able to say like that. Good. Yeah.
Exactly.
Sorry. So there are very many ways to run Kubernetes, very many different platforms in the clouds, and some ways to run them in local environment. We have Minikube to run it in local environment. So it exists for a longer time and more people know that, but it's also not enough because, well, Minikube allows you to run only one Kubernetes worker at a time, and you don't want to run 5 of the Cassandra nodes, for example, on a single worker. It's a very bad idea. As soon as you lost this worker, and in the distributed environments, it's just a question of a time when you lost all your database. That's not what you want. So what you want in a real case, you want to have your database and application also spread it over multiple nodes or multiple Kubernetes workers. To do so at a local environment, in the test environment, within a single laptop or within a single machine, we use so-called kind or Kubernetes in a Docker. Yes, we put Kubernetes in your Docker so you can Docker while you Docker. And this, yeah.
So this is for development, right? So I think it's important to understand it allows you to create several nodes on a single host. And it's not necessarily how you would want to run this in on a proper Kubernetes cluster. This is a development.
Yeah, exactly. Thank you. Yeah, I forgot to say the main thing. That's the development environment. That's local environment. That's not for production usage. We use kind to emulate multiple Kubernetes nodes on your single laptop, which is obviously not for the production purposes, but for development purposes. And for our exercise, yeah.
But it lets you play with it, right? It will give you all the ability to play with those nodes and to try it out and to experience how Kubernetes works. So please really give it a go. It's a great tool.
And we have two options as said, your laptop or cloud environment with our machine. If you can install, I would actually show it. Give me a moment. Okay, so we have my browser and we have this famous Cassandra Workshop series repository at the GitHub. I'm very thankful for you to all your positive marks and stars and forks and so on. Thank you so much. And now we are at the week 5. And in the README of week 5, we have specification how to prepare for them exercises. So don't forget you do it after the workshop, not during the workshop. Now please focus on what we are showing. And if you want to do it locally, you have to install Docker, Docker Compose, Kubernetes, watch kind, and create a kind cluster. If you use a machine which we deliver it to you, so cloud instance, if you want to use that but didn't receive it, please contact Jack Fryer. So when you will receive a link like that, let me copy that for you. So you will receive a link like that. That's my instance, workstation Z, some numbers, blah, 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 blah. And it has terminal directly in the web. So I can go and log in. User will be yesi2-user. Password will be data stacks. And don't forget it's Linux, so it doesn't show your password as you're typing it. So I've just typed the password, but you don't see it. No asterisk, no nothing. And I press enter, and I'm logged in. Good. And here I can say, for example, kubectl get nodes. And you see, kubectl, as said, is a program to contact Kubernetes, so kube controller. Get nodes. We have one master and 5 workers, and they all are here locally. Good. So if you start on your own, please go through the installation steps, because even if you have Docker, you may need kubectl and kind. And if you work directly with our node, you can start with step 7.
Yeah, all this is installed for you on the cloud instance, so you don't have to do it yourself.
Yep, good. So, and last things we have to do during this exercise is to be that way. I will contact my node using different way, actually, because if you have an SSH terminal, if you have bash or putty or things like that, it will be more convenient. So I will go to my iTerm. Let me switch you to see my iTerm. Good. So I can say SSH to contact to this node, EC2 user 80, and oops, contact my node. Yes, and boom, I'm in. I don't have to put password because I'm logged in for these machines already. You will need to put your password. Good. So I'm in this machine, and now I can do the required things. So what's the required things? Let me change something. So good. First thing we have to do, we have to create a namespace. So you remember, we want to keep it logical and reasonable and clean, like clean code, clean Kubernetes cluster. So we want to create an operator. And I do it with the command kubecontrol create namespace Cassoperator. So Cassoperator is just a name, namespace Cassoperator created. And next, what I want to see, I want to take a look at my storage classes. Because, well, storage classes are important for me. Storage classes is the thing what we really need when we work with database, because database works with persistent data. You don't want your database to lose your data all the time. So I ask for storage classes. And storage classes is very simple. It's a default, very simple, standard storage class you use working with kind. And that's not what really match our requirements. If we want to get deeper details, we can also say kubectl describe storage class standard, because, well, that's the name of this storage class, and we see what it's a default class. We see some annotations. We will keep it not explain it yet, because otherwise you see Kubernetes is a big thing. If we do a deep dive, it will require 16 hours, not 2. But I will be happy to do it for you next time. And
but that's actually a good thing to remember. You can always describe a pod or a service or a storage class to get more information about it. So while you explore your Kubernetes cluster, you can get those names of those resources that you want to investigate and describe them. like what Alex just did.
Yes. So we want to adjust the storage. We want to use a little bit differently configured storage, and we can do it like this. But before we do it, let me explain you something. So Kubernetes is very well designed tool if you want to have your infrastructure as a code. What does that mean? Infrastructure as a code is a great concept. You usually have all your software source code in GitHub or whatever Git repository you have, and you can track that, and it's transparent. You can see its state in every moment of the time, like what was that 2 months ago, who committed this bug, whom to blame, and so on. But when you work with infrastructure, doesn't matter if it's hardware or software or something, you don't have abilities like that. And there is a very great thing getting stronger last years, call it infrastructure as a code. It allows you to describe your infrastructure in configuration files and then have them under Git control and see what was applied when and what exact infrastructure you had 2 years ago. And sometimes it's very, very useful. So you can create this storage class on your own completely. But what we recommend you to do is to have the files describing your infrastructure. And if I open this file, oh, by the way, let me clean up and do it again. If I open this file, it's just a manifest, Kubernetes manifest, explaining what's exactly we have to use for this the storage. So storage class is important for us. And then I can apply this file with, with the following command. So it will be kubectl, you know this command already. Then I must specify namespace because I want to apply it for the Cass operator namespace. When I give the command apply, and then I specify what I want to bring the changes out of file, so -f file, and I specify the file I've shown you already. And I press enter, and I see this storage class has been created, and I can say kubectl get storage class, and I see all my storage classes are available here. Good. So, first part is done, and now we are ready to work with the Cassandra operator. And what's the Cassandra operator? I have to say a word about that. Cassandra operator concept, and well, any operator concept is very simple. The point is, if you run a complicated software, and well, Cassandra is a big and very powerful system, but it's not the easiest thing to manage, then you have to consider many different things, and when you have to be very careful in your actions. And then when you try to manage the system like that, it gets really hard. And for example, if you want to put change something in your Cassandra application or any application you manage that's not about Cassandra, that's about application management, you want to change a setting, and let's say this change requires a restart of the application. You cannot just go and throw this change to all the nodes. Why? Because when all the node will restart, all application, all the pods will be restarted to apply your change in the variable or environment variable or some setting and like that. And your application will have what? Downtime, because all the nodes are being restarted at the same time. Instead of that, when we want to put some change with Cassandra and we have a Cassandra operator taking care of, we set this change, and then Cassandra operator will apply this change on one node by one. It will not take down the next node as soon as the first one is not started and not ready to work. And that's very important thing to understand. Or deployment running a new node of a Cassandra, it's also you have to consider some things, and that's all done by Cassandra operator for you. So it's like your Cassandra administrator, but for free because it's open source, and that's really great. and it saves a lot of time. When we want to install Cassandra Operator, first thing we do, and again, we have to apply the Cassandra Operator file, as we did already for the storage. But let's take a look first how it's, oops, what's inside this class. Yeah?
Hey, Alex. Can you zoom out a little bit so that we see the full commands and everything that you put into the terminal?
Oh my God!
Your prompt is very long.
Yes. Just a second.
Yeah.
Oh, I'm so sorry. Display laptop. Now it should be better. Bettina?
I'm waiting for the overcome the YouTube lag.
Oh, yes.
So, let me just see.
Yes, but I think now it should be good.
Yes,
Yeah.
it's better. It's better. It's a bit harder to read, but at least you see the full command now.
So, if I open this file, there are really a lot of things. So you see it's scrolling and scrolling and scrolling, and that's a really big file. That doesn't matter for us because the main thing, the Cassandra Operator is easy to install, as we just apply this file installing Cassandra Operator version 1.3, and then all the things will be done for us by Kubernetes. And if we take a look, we see some things happening here. And I don't have time to explain all of that, but we see what the namespace Cassandra Operator was configured. And what's important for us, service Cassandra Data Center Webhook service was created, and application Cassandra Operator was created. That's the final and the most important thing for us. So Cassandra Operator is created and it's running now. And there is an interesting trick. You may ask, how Kubernetes runs applications? And the answer is actually obvious. When you install Operator for Cassandra or for Prometheus, for Grafana, for any other systems, they run just as a simple pods. So if we say kubectl get pods, and the namespace is going to be Cass Operator, and oops, clear once again. So you will see what it's just a pod running in the system, and that the Cass Operator will execute steps for me in the Kubernetes. Good. So now we can ask system to explain something about our pod as this Cass Operator is running. And I'm going to do this kubectl. I need to specify the namespace Cass Operator. And I want to say describe. And I want to give this ID. Oh, oops, of course.
Yes, don't forget to specify the namespace, or you might not find it, right? So something to bear in mind. And
notice this command, describe. You will really need that. When you have to describe something, you say kubectl describe what? You want to describe pod, and you give the ID of this instance. So, and we see the name of that, namespace of it's located, which node it's running. So you see it runs at the node 3. And many other important things. And in the end, you may see a log of the events happened to us. So successfully assigned a Cass Operator to worker 3, pulling images, because, well, everything is an image container pod. Don't forget image container pod. And we have this pulled, we have pulled this image. It took some time. And we created container and we started container. Very well. Good. Now, okay, so we have operator available, and now we start thinking of a Cassandra cluster. And I'm going to execute this command, and this command should look familiar to you, but first, let's take a look at the file again. So which file we are going to apply to the namespace Cass operator with the help of a kubectl. It's a very, very simple thing explaining to Cass operator which kind of a Cassandra data center we are going to deploy. So what it's going to be? Which kind of that? What is that? It's a Cassandra data center. It will have a metadata with a name DC1, cluster name will be cluster1, server type will be Cassandra, and version 3.11.6 in this case. We will not secure the management API, usually it's recommended, but well, it's just a demo. And the size of a cluster will be simply 1. And we have some storage config, so notice we are using storage class server storage we have created earlier. And it will have 5 gigabytes of memory. And this configuration goes to Cassandra YAML. So we are specifying kind of authentication, authorization, role managers, and so on. And for JVM, Java Virtual Machine, so Cassandra runs in JVM, we specify heap size and max heap size. Good. So I will apply these. Oops. I will, oh my God, sorry. I'm to apply this file. And we see what Cassandra data center is created. And now I can tell watch is just a command to watch what's going on inside. It's not a Kubernetes command. kubectl minus namespace Cass operator get pods. And you see what pods we have right now. Cass operator is running. It has been started almost 6 minutes ago. And we have cluster 1, DC1, default, stateful set. So it's Cassandra is a stateful set because it works with a persistent volume. And we have 1/2 running and some seconds. And now, very good question. Why Cass operator has 1 of 1 and cluster 1 has 1 of 2? That's what I told you already. Those are not containers, but pods. And every pod may have 1 or more containers. And Cassandra operator pod has 1 container. That's why Cass operator 5.6 FCB blah, blah, blah has 1 of 1 container of 1. But cluster 1 DC1 default STS0 pod has 2 containers, and the second one now is ready. How come? Because the Cassandra pod has 2 containers. One Cassandra for management API and one Cassandra by itself. Okay, so Cassandra looks like ready now. And we want to go and take a look. No, it will be fine. So we want to describe data center, and we see what this data center consists of. And there is a lot of things because, well, Cassandra data center is not so small, of course, but we see what kind. Notice again, it's important. Kind, Cassandra data center. This resource type was created by Cassandra operator, of course. And there are some different data what may be useful for you when you're running Cassandra in Kubernetes. And we see some specifications we have applied, so we will apply it for sure. And important things for us, storage config is applied. And we see Cassandra Operator progress status ready, some conditions, and story of this Cassandra data center. So created service, Cassandra cluster, Cassandra data center consists of 3 different services. Oops. And so story of this data center in general. Good. I see a question. Is it possible to connect to the Cassandra running on Kubernetes from internet? In other words, can we create Kubernetes ingress and expose the Cassandra service to the internet? Of course. I mean, that's your cluster and your deployment. And if you find what you need to have incoming access to the Cassandra from the internet, that's absolutely possible to set up. So there are different ways to reach that with ingress, with port forwarding, and so on. That's out of scope for this workshop. But in general, that's about ingress controller and load balancer. And well, that's how it works. So it's absolutely possible. Good. So let's work a little bit with our Cassandra installer then. So I want to log in and execute some commands, but it's not so easy because this Cassandra installation is the secured. So first thing I want to do is to clear the screen, and let's take a look at this command. First, kubectl, okay, Kubernetes control, namespace. No surprises, we work with namespace Cass operator. When we want to get, okay, we want to get something. What we want to get? We want to get a secret. As I said before, Cassandra also executes secret management and things like that for your Kubernetes cluster. Oh, sorry, Cassandra. Kubernetes executes this kind of work. And now I want to get the secret call it cluster1 super user, and I want to have output in YAML. Good. And there is two main things for us important. The data, so again, it's kind of a secret. And we have a real data stored there, password and username. And we want, so we packet with this base 64 algorithm, and we want to unpack them. So first thing I want to do, I want to unpack username. Username will be the same for every one of you. So username is the one we see here right now. And I can simply run this command. So I'm sending these, it may look unfamiliar for you if you don't have experience with Linux. Don't worry, it doesn't matter right now. The only thing we want to do is we want to unencode this cryptic message and see how it works, not in base 64 format. And the answer is cluster1 super user, as simple as that. We have cluster1 super user as a username, but we also have a password. And I want to, yeah.
So the username is going to be the same for everybody, but if you follow the instructions from the README, you will need to decode your own password.
Yes, password is unique, and now I show how to decode your password. So that's my coded password. I want to encode it. And I need to say echo, copy paste my password, and let me, oops, oh my God. Let me hide us for a second so you will see everything. So I'm echoing my password, then I want to send it to base 64 and get the output. Yes, and output is also going to be pretty long, but not so long. That's the password for my user super user cluster, super user 1. Good. So next thing, I want to log in. And I'm going to connect to this container, connect to this pod, connect to this container. And to do so, I go. It's going to be, as you could guess, kubectl minus ncas operator. Good. I need to exec, so I need to execute a command. I will need an interactive terminal, so -it. What I'm going to connect, it will be this cluster 1 DC1 default STS0, cluster 1 DC1 default STS0. Oops. And what's the command I want to execute? I will need bash. And now I'm exactly in the container, and it will look like Linux to me. I can ask what's my current folder, what's the current processes, and there are some processes running, so Cassandra and required things, and metrics collector and others. And as long as I'm here, I can also connect to Cassandra using SQL. So first of all, what interesting for me, I can say node tool status. If you don't know yet, well, basically you should, because it's week 5, and you should have do your homework. So maybe you know what the node tool is. Node tool is a Cassandra command to work with a cluster. And in this case, I ask Cassandra node tool to show me the status of the nodes. And that's pretty simple. We have up and running, up normal status, one node cluster, because I've created only one of them. And as a next thing, I want to contact my SQL-SH. So I will pass my password. I will add SQL-SH command, and it will look like SQL-SH and user and password. Good. So I did everything correct. And now I'm in Cassandra cluster, so I can do a normal SQL-SH command you did before. So first of all, I'm going to create key space. Oops. Just a second. My mouse got lost. I hope. Oh, okay, my mouse is back. Great. So this command must be familiar to you. That's create key space, if not exist, killer video 1 with replication, network topology strategy, DC1 amount 1, very simple. So we will use network topology strategy. And for the DC1, that's the default DC, we run Kubernetes cluster this time, and durable writes. And we will have only one replica because, well, we have only one node running so far. So I can execute this command. And looks like everything is good, and we have the key space. So we may say describe key space. Good. And we have a short list of our key spaces. So system, 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 and killer video 1 we have just created. Very good. And we can set this key space to be the default for us. Killer video 1, boom, boom. Very well. Log it in. Now we are going to create some data we will use very soon. So what we are going to do, create table if not exist users. Well, it's newly created cluster, so very doubt I have this table there. Create table if not exist videos. Okay, we will need that, and then put some data into that. So I'm going just to copy paste this thing and go ahead and paste it here. And it should be ready for me. No errors. Select all from users. And yes, all the users I wanted to insert are there. And we have videos as well, so we are going to get back. Cassandra is up and running. This single node cluster is available, and that's great. Now, let's move on and add some power into that because, well, we don't usually want to have one node Cassandra cluster in production. Don't forget to run the last time to apply the changes and run Cassandra cluster last times. We use it this file, Cassandra 12 Cassandra cluster 1 nodes YAML. Now we will apply the file Cassandra 13 Cassandra cluster 3 nodes, and that's the difference. So let's take a look what's the real difference between those two files. And I put the comment and I see the difference. And difference is very simple. Files are absolutely identical, but size before was size 1 and size now will be size 3. So I will apply this change. So I am saying kubectl, Cassandra Operator namespace, apply file cluster 3 nodes YAML. And Cassandra Data Center, Cassandra Data Stacks, DC1 configured. So Cassandra Data Center is configured. Now let's do thing we did already. I'm going to watch what? kubectl namespace Cass operator, and we will set get pods. And let's take a look what's going on. So we have first pod Cassandra Operator. Of course, it's running for 20 minutes already. We have first pod Cassandra cluster of 2 containers running for 15 minutes, and 2 new pods are initializing. Why 2? Because, well, we already have 1 Cassandra node and we are going to have 2 more, so 3 altogether. And we see what one of container in every pod has started already. That's the app management API, which is much easier to start and much less work to do. And now we will wait for Cassandra to start. And in a couple of minutes, it will be ready. Yep. But I think in 30 seconds approximately it should be done, at least all the times I did that before. But well, that's actually interesting point. So let's get back to our first node. And I will simply use my previous command, Cass operator exec, to get to this node. And I can ask that about node tool status. And we see what nodes are joining the cluster. So first node has joined the cluster already. And we have 2 nodes in this one. But if we say watch node tool status, third node will join this cluster in next. Oh, yes, here we go. That's it. So next node will join us very soon. And it's bootstrapping. So you see the status up normal, but the middle one is up joining. That's one of the things what Cassandra Operator watches for you, because if you try to create too many nodes at once, the amount of data transfer in the network will be enormous, and then all the cluster may be just too busy. And now it's up and normal. Congratulations, we are now running 3 nodes cluster. Great. And if we take a look at one more thing, and I say like get pods, so we have different pods here, and I can say kubectl. I have to specify namespace, Cassandra Operator. And I can say describe. Do you remember this command? Describe is a very important one. Describe pod, and I give this name. So if I scroll up a little bit, I can find information. What's interesting for me? Yes, note, this one runs at Cassandra Worker 2. Okay, but we have more than one node. And STS0 runs in it. Node Cassandra Worker 4. And as you guess what I'm getting to, you would say what STS2, third Cassandra node, will be running at node Cassandra Worker, just Cassandra Worker, no number. So first worker, Cassandra Worker 1. And that's not a random allocation. By default, it will try to put your nodes to different workers, reaching this way. So highest availability for your cluster. So if one node is down, other will be working, trying to spread that over the system. Good. So what's next? Oops. Yeah, so we've seen node tool status already, it's running. Now we go to some interesting points. So we want to connect back to this cluster. Good. And we are going to connect to CQLSH. Okay. So I will ask to describe keyspace killer video 1. And see here is replication factor is 1. As designer, we asked that to be replication factor 1. But we have 3 nodes cluster now, so we have to change something. That's a very interesting point. So yes, you have added maybe 1,000 nodes to your cluster, but every key space is configurable, and maybe you don't want this key space to be over all of the machines. So you have now to configure your key space to use those additional nodes. And what we want to do now, we want to alter key space. Killer video 1 with replication plus network topology strategy, DC1 replication factor 3. So we explicitly tell Cassandra to set the replication factor 3 from 1 for the killer key space killer video 1. And I go for that. I put alter key space, set replication factor 3 for this key space. Oh, oops, of course. Good, it looks like it's changed. And now I will ask you a question, but you don't answer, just think about that. Do we have this data now of all over the nodes physically replicated or not? Don't answer, just think. We have some records there, users, videos, and so on. And they definitely were on this node as it was the first one when we created. But now we have replication factor 3. Do we have these records already stored on the new nodes or not? And let me show you some interesting tricks. It's a pretty important moment. Well, first of all, if we ask to describe key space killer video 1, we will have, of course, replication factor 3 set successfully. I had no errors and warnings, so it's fine. Now I want to set consistency of my queries to be quorum. consistency level set to quorum. And I also want to use one very nice Cassandra command called tracing on. What does that mean? Tracing, now tracing is enabled. Very well. What does that mean? It means what now I will receive not only just an answer to my queries, but I will receive tracing data. So how exactly this query has been executed. And that really helps to debug some things. And now I'm going to record from a table videos. So I'm going to select everything from killer video videos, given a video ID 999-333, blah, blah, blah. Boom, a lot of data. I will make it a little bit smaller, so you will be able to do that in the end. My term behaves weird today, but okay, that's what we have. Okay. And there is a lot of data because, well, we have enabled tracing. First, let's take a look at the answer. Answer will be above. And yes, indeed, as we requested for data from Killer Video 1 videos, we have all the data here. And that's the record I've inserted recently. And here we see the execution of this query. So everything step by step. Execute SQL query. Parsing, select, blah, blah, blah. So first we start with parsing. We are executing single partition query. And that's a yes, of course, it's a single partition query because I'm searching by ID and ID is my partition ID. So I know exact partition and everything. We have K-cache hit. We have many additional things interesting for us. And the main thing I want to show should be somewhere downwards. Yes. What I'm looking for is read repair, and it was here just a moment, and that's what I want to show you. Read repair message received from. Okay, what does that mean? You remember I've asked you recently, how do you think is data is replicated to other nodes already or not? The correct answer is not, it's not replicated. And now you may be like, hey, Alex, you promised me what Cassandra will do a lot of work for me. And what I have to do now, I have to replicate everything manually. And answer is yes, Cassandra will replicate it for you. But as long as we have 2 tables and 3 records, when we don't think so much about the network traffic, when you work with petabytes or dozens of petabytes, or maybe in the future zettabytes, you really have to think what you are doing and watch your every step. If Cassandra would try to replicate automatically any change of your key space, then at some point you may find out your network is paralyzed because you are transferring petabytes of data over multiple data centers. And that's not the behavior you want to have on your distributed, geographically distributed database. So the answer is just adding a node and just setting replication factor equal 3 is not enough. Then you have to initiate data transfer on every next node one by one, because otherwise you will try to pull the petabytes of data to multiple nodes at once, at the same time. And your network administrators will be very, very unhappy, and they will maybe try to find you and make something bad to you. So in this case, we see what Cassandra, during executing this query, found a read repair situation. What does that mean? We set our consistency level to quorum. It means what we will require data from at least 2 nodes. And we found out what 1 node has this data and second node doesn't have this data. And it means what? We will return the latest up-to-date data. which store it on this node, and we will initiate a read repair. So repair message to all the nodes in noticing them, notifying them what they don't have existing information, and therefore they have to grab this data for them and to be consistent. But in general, as soon as you add new nodes and set replication factor, you have to go and with node tool specify what you need to retrieve data from the other nodes. Okay, then. So what's our next step? We are done. We are done with this part. And last thing I want to show you is the changing of the Cassandra configuration. And that's a powerful feature of the Cassandra Operator. So it happens from time to time you want to change something in your settings. And now, okay, let me make it a little bit bigger. Good. And now let's say we want to change settings for our, oh, sorry, one more time. We want to change settings for our Cassandra cluster. And last time last change we applied to our cluster was cluster free nodes YAML file, where we had 3 nodes instead of 1. Okay. And now we want to apply another file, 3 nodes new config. And let's take a look what changes, what kind of a change set we are applying to. Change set is again extremely small. We want to change settings for commit log. I hope you know what's the commit log already because it was in your homework. But if you don't, in very brief, commit log sync period is the time when commit log is being synced. And well, that's not a maintenance course. I will not get too deep into that. But the point is, this is an important setting, and this setting cannot be applied without restarting the Cassandra. And what you don't want to restart all of your 3 nodes at once. So if you do restart all of the 3 nodes at once, what happens then? You have downtime, in some cases pretty long downtime, and that's what you don't want to have. To solve this problem, we have a rolling upgrade, and that's exactly what we will see right now executed. So let me move on. And I will apply this change set. So basically, I will tell Cassandra Operator what for this cluster I want commit log sync period in 11,000 milliseconds. Cassandra data center configured. But this change is not really applied right now, because if you would take a look at the pods, now we see what, oh my God, last pod is being terminated. Why? Oh, I told you. The only thing we want to have persistent is your data. And containers or pods are ephemeral. Those are cattle. And in this case, I want to apply changes. I will simply terminate, it's done already, the pod, and create a new pod. And as soon as the first, as a new pod will be ready, I will switch and take down the next pod, take it up new, a new one with new containers, and start, and then proceed to the third one. That's exactly the rolling upgrade happening right now. And we will take down and create new one by one all the pods and therefore containers. And it will take some time because we want to gracefully stop Cassandra, not abruptly kill it, but gracefully stop. So it takes some time. Okay, and that's exactly what's happening. We see what first or last, better to say, pod has been terminated. Now it's running again, and next pod is now being terminated. So we disable management API, we notify another Cassandra nodes what this one will be not available, and management API is taken down, and then Cassandra by itself at this pod is taken down. We have 0 of 2, and we will have new pod being created right now. In a moment, in some seconds. Boom, yes, so we are initializing. Oops. So, and as you could guess, as soon as this one will be ready, we will have next one also stopped. If now we describe the pod, we will see what our commit log sync period is to be 11,000. So we can stop them. Okay, yes, and that's exactly what I told you. Now the last Cassandra pod is being destroyed to start new with new settings. So if we quit this window, oops. Okay, wrong button. But I want to use this one. So we go through settings and we will have somewhere here, let me find. Yes, commit log sync period in milliseconds with config file data, and Cassandra instance is running with the settings we gave recently. So we did 2 parts of the exercises today. Main part of the Cassandra, installation and preparation and storage class, and when we worked with Cassandra. We installed Cassandra Operator, we installed a single node Cassandra cluster, brought some data to there, replicated our cluster to 3 nodes, moved data with read repair to the proper things, and should see how read repair works. And in the end, we executed a rolling upgrade, changing settings for all of our nodes one by one, completely done by Cassandra Operator. As the next step, and I very recommend you to do these on your own, the same steps. It's all here in our week 5 of DataStax Academy Cassandra Workshop series. And next steps, which is also very useful if you are into metrics management and visualization, like you cannot control what you can't measure. Next part will be about them monitoring a cluster. So if you want to understand how your cluster breathes, what's the current situation, we use the special tools called Prometheus and Grafana. Some of you may know them already. They're very often used in monitoring. And we do all the required steps described here to have some nice fancy pictures in the end of how your cluster works. And I can try to make it bigger. And I recommend you to do the exercises on your own. Yes, like that. And I recommend you to do the exercises on your own, so you will see the behavior of a cluster and all the steps required to install these monitoring tools to have your job done with that. And we did therefore Cass Operator. We worked with stateful sets in live. Custom resources, that's what the operator defines for you, because Kubernetes by itself works with simple things like pod, service, and things like that. And it can't manage the whole Cassandra because it's not the Kubernetes job. but Cassandra Operator creates the custom resource definition, which is, as we've seen already, Cassandra Data Center and other things required for Cassandra to work. Then operator is said as an extension which makes you using the things with ease without manual need to do the things, to do too much actions to reach some goals, like Cassandra Operator make a lot of work for you. And final one we will cover today is basically, I will not cover Prometheus, but let's get back to a week 5 homework. Week 5 of the homework is very simple for that. Just finish the exercises from a previous week and do the exercises following the guidance at GitHub on GitHub, and use our help in community.datastacks.com and Discord. And you know what to do. If you can run your Docker on your own, do it on your own. If you need our machine, then you have Jack Fryer in the chat. And if we don't have enough instances right now, I will spawn a new one. So you will receive your email within next hours. So don't be in a hurry. If you haven't received your credentials and link yet, don't worry. Don't push everyone in the chat. You will receive them in the next few hours. If you receive nothing, contact me, Aleksandr.VOLOCHNEV@datastacks.com, preferably by email or maybe on Discord as well. And don't forget to fill the validation form of the week. That's important part of the homework. That's how you verify your presence. Important update on Astrocaton. We have 4 weeks to build real application. End date is now set after the 8-week workshop. So end date is August 20th, 12 p.m. Pacific Standard Time. And on 26th, we will do Ask Me, Ask You Anything special episode with surprise, unknown sync winners, and all the other things. Oops. Thank you so much for being with us.
And if you like these,
yes, please.
If you like these workshops, just like us on YouTube so we get better visibility. Don't forget to show your appreciation. That would be great. So, and subscribe to not miss out.
Yes, you see, the more subscribers and likes we have, the easier we can persuade our bosses. So we need to run those workshops more again, getting deeper into Docker, getting deeper into other topics. So that's in your own interests. Thank you so much for being with us. I'm very happy what you've seen it all, and I'm very happy what we were here with you. Thank you so much. That's great to be here with you, and I see so many positive feedbacks and so many questions, and that's incredible. So see you next week. Thank you so much. And ciao.